Okay, chapter 13 review. First one, find the value of each expression. Sine of theta, given cosine is square root of 2 over 2. So I make my right triangle. The adjacent is 2, the hypotenuse is 2 because it's cosine. I try to find this so I can do sine. X squared plus square root of 2 squared equals 2 squared. X squared plus 2 equals 4. X squared equals 2. Therefore, x is square root of 2. Therefore, sine of theta is equal to either a positive or negative. Opposite was square root of 2 over hypotenuse was 2. Within this range, I look at my unit circle, and sine is negative there. So it's negative square root of 2 over 2. Find secant if cotangent is square root of 2 over 2. Well, cotangent is the reciprocal of tangent, so that means tangent is 2 over square root of 2. So, right triangle. Tangent is opposite over adjacent. Okay, square root of 2 squared plus 2 squared equals x squared. That's 2, that's 4. That's 6 is x squared, so x is the square root of 6. Secant, which is reciprocal of cosine. I'm going to start with cosine. Cosine is the adjacent divided by the hypotenuse. Positive or negative. Which means secant is the reciprocal of that. Positive or negative, square root of 6 over square root of 2. Rationalize my denominator. I get positive or negative square root of 12 over 2, but the square root of 12 simplifies to 2 root 3 over 2 because it divides by the perfect square 4. And square root of 4 is 2. Last but not least, secant, within this range, cosine is negative, so secant is negative. Negative 2 root 3 over 3. Oh, wait, those 2's cancel. Negative square root of 3 it is. Find cosine of theta if secant is 2. Well, those two are reciprocals, which means cosine of theta is 1/2. Moving on. Find cosine if cotangent is negative 4/5. That means tangent is negative 5/4. Create a right triangle. Tangent is opposite over adjacent. Leave the negative off of there. It doesn't help. X squared is equal to 4 squared plus 5 squared. That's 16. That's 25. Add them together. I get 41. So x is the square root of 41. Cosine, being the adjacent over the hypotenuse, is a positive or a negative 4 over square root of 41, which is a positive or negative 4 root 41 over 41. And cosine in the range of 270 to 360 is positive. Okay, simplify the following. When simplifying, remember, you're going to go through those red flags. First thing I notice, the first thing you look for is the angles. My angles are not all the same. I've got thetas and negative thetas. So on my identity sheet, negative thetas are on the bottom. Sine pulls the negative out. Tangent pulls the negative out. Cosine just becomes positive. Done. There we go. That's what I'm looking for. So 1 plus tangent of theta times sine pulled the negative out. So negative sine of theta times cosine just becomes positive. So to rearrange this a little bit, I'm going to multiply, and when doing that, I'm going to pull that negative. because these don't really multiply, but I don't want the negative in where it was. Okay, so other red flags: multiplied reciprocals, nope. Squared trig, nope. Algebra, nope. Factoring, nope. Adding fractions, nope. When in doubt, change everything to sines and cosines. Ooh, I've got cosine in the denominator getting multiplied through the numerator, and sine times sine is sine squared. Well, sine squared is getting subtracted from 1. Here's my identity that deals with that. If I subtract sine squared, I get 1 minus sine squared. Remember, don't actually write on your blue sheet. Okay, so 1 minus sine squared is cosine squared, so that means this becomes cosine squared. So, next one, sine of 2 theta, cosine of negative theta. I see angles that are different again. I see a negative theta and I see a 2 theta. It was sine of a negative theta, so that becomes negative. Or was it cosine? I think, actually, it may have been cosine. Either way, sine pulls the negative out, cosine just stays positive. And then there was a sine of 2 theta, which becomes 2 sine of theta, cosine of theta. So, this becomes 2 sine of theta, cosine of theta, over cosine, the negative just comes out, or sorry, negative does not come out, it disappears, and so that just becomes cosine. Cosines cancel out, I'm left with 2 sine of theta. Okay. Simplify each expression. Cosine of 90 degrees minus theta plus cosine of theta, cotangent of theta. My angles are not all the same. Now, we've been working a lot lately with the sum and the difference identities, which you can use here, but always double check when you see 90s, is it a cofunction identity? It'll get you the same thing, but it's easier. And it was cosine of 90 minus theta, which is sine. So let's do that direction instead. So I get sine of theta plus cosine of theta, cotangent theta. I do not have multiplied reciprocals. I don't have any squared trig. I don't have algebra. I don't have added fractions. I'm not going to factor sines and cosines. Okay, so that becomes sine of theta plus cosine squared theta over sine of theta. Okay, now I'm adding fractions. So I'm going to get a common denominator by multiplying both the top and the bottom by sine. Don't lose your thetas. I get sine squared theta over sine of theta plus cosine squared theta over sine of theta. So that becomes sine squared theta plus cosine squared theta. I wrote too large here. Over sine of theta. I see squared trig, and sine squared plus cosine squared is the identity perfectly. It becomes 1, and 1 over sine is cosecant. Okay. Problem 8, cosine theta plus cosine theta tangent squared theta. My angles are all theta. Sweet. I do have squared trig, but it's being multiplied by things. So that causes the Pythagorean identities to not necessarily work so well because I need adding and subtracting to either other squareds or to ones. I don't have any algebra I can do. I'm not adding fractions. Ooh, but I could factor. There's a cosine on both of them. I can factor out a cosine. It would leave me with 1 plus tangent squared theta. Now, if you didn't factor, if you went through and changed things to sines and cosines, you're going to get the same thing. You're just going to do it the long way. Okay, tangent squared plus 1. I believe that is a Pythagorean identity, and actually, I know it is, but hey, by the way, it's Pythagorean identity. Look at that. Beautiful. Tangent squared plus 1, aka 1 plus tangent squared, is secant squared. So I get cosine of theta now getting multiplied by secant squared theta. Those are multiplied reciprocals, but secant is squared, which means there's still a secant left over. Okay, 2 more simplifies. Then we get to the verifies. Cosine of pi over 2 minus theta, cosecant of negative theta. My angles are not just thetas. Now, again, I see a plus or a minus with angles, but I would check the cofunction identities first. Okay. Now, we have to pay attention, though. That problem had cosine of pi over 2. So let's go back. Cosine of pi over 2 minus theta becomes sine. And then I had a cosecant of negative theta. Now, I don't have that for an identity, but remember, the negative angles work for their reciprocals as well. So if sine of negative theta is negative sine of theta, that means cosecant of negative theta is negative cosecant of theta. So this was sine of theta. This is negative cosecant theta. Those are multiplied reciprocals, so they become 1, but it is negative. Okay. Next. Cosecant theta, tangent theta, minus tangent theta, sine theta. Okay, so let's see. I don't have different angles. I don't have multiplied reciprocals. I could factor. Unfortunately, if I choose to factor, I get cosecant minus sine, and that's not helpful. Factoring really only works when you recognize that factoring is going to get you a, Pythagorean identity is typically what comes out of it. So, that's not going to work. I have to take a different approach. Okay, I don't have multiplied fractions, added fractions. I don't have algebra. Sines and cosines. 1 over sine of theta getting multiplied by sine of theta over cosine of theta. Minus sine of theta over cosine of theta. Getting multiplied by sine of theta. Sines will cancel over here. I'll be left with 1 over cosine minus. Sines are going to multiply over here to get me sine squared over cosine. Subtracting fractions, they have a common denominator nicely, though. Ooh, squared trig. 1 minus sine squared. I've done that one before. I've done that one many times before. By now, we should notice that 1 minus sine squared is a modified identity. Again, don't write on your blue sheet. And it gives me cosine. Specifically squared. So cosine squared theta over cosine theta. Cancel out a cosine, and I'm left with a cosine. Now, Remember, as you are going through the verifies, that you need both sides of the verify at all times. You also need your thetas at all times. Okay. Tangent cosine plus cotangent sine equals cosine plus sine. Okay. So, looking at this problem, my angles are all the same. I don't have multiplied reciprocals. I don't have fractions getting added. I don't have squared trig. I don't have algebra. I don't have factoring. Sines and cosines it is. Sine of theta over cosine of theta, getting multiplied by cosine of theta, plus cosine of theta over sine of theta, getting multiplied by sine of theta, is equal to cosine of theta plus sine of theta. Ooh, I'm multiplying fractions. Death to the cosines, death to the sines. Sine theta plus cosine theta equals cosine theta sine plus sine theta. Now, remember, both sides have to be the exact same, so I need to reverse one of these sides. It doesn't matter which one. Just make them the same. Okay, cosine over cotangent plus sine over tangent equals sine plus cosine. My angles are all the same. I don't have multiplied reciprocals. I am adding fractions. That looks terrible. I generally stick with adding fractions more commonly when they're like have something in common. These ones have nothing in common, so I'm going to wait on the adding fractions. It could work, don't get me wrong. You're going to give yourself more work, so I'm going to wait. I can't factor, don't have algebra, sines and cosines. Specifically on this one, I'm changing things to sines and cosines without adding the fractions because of the fact that I noticed the other side is all sines and cosines already. And I've got sines, I've got cosines, I've got tangents and cotangents, all of which will generally have some canceling going on. So I'm just going to do this and see what happens. Okay, to divide fractions, you multiply by the reciprocal. So cosine theta is getting multiplied by sine of theta over cosine theta. Ooh, I see what's going to happen there. Sine of theta is getting multiplied by cosine theta over sine theta. Ooh, I see what's going to happen there. And I do need both sides of the equation at all times. Death, sine theta plus cosine theta is equal to sine theta plus cosine theta. Keep going. Secant squared theta minus 1 is equal to sine squared theta over 1 minus sine squared theta. My angles are all the same, but I see a lot of squares. Pluses and minuses with 1s. So 1 minus sine squared, I still have that up here already even. Right here. So that is already what I want. Make that a little easier to see. And then the other one was secant squared minus 1, which is tangent squared. So this becomes tangent squared. This becomes sine squared theta over cosine squared theta. Wait a second. Sine squared over cosine squared is indeed tangent squared. Done. Okay. Cosine plus 1 over sine equals cotangent plus cosecant. Okay, I've got a couple of approaches on how to deal with this one. There's the one that I find easier, but the one that's more intuitive is probably changing everything to sines and cosines because my angles are all the same. I don't have factoring. I don't have adding fractions. All that wonderfulness. So cosine theta over sine theta plus 1 over sine theta. Ooh, I'm adding fractions and they already have a common denominator. Cosine plus 1 is just cosine plus 1 over sine, which is what the other side is. Okay, question 16. Cosine 2 theta minus cosine squared is equal to negative sine squared. I have a situation where my angles are not the same. Specifically, I see a cosine of 2 theta, which makes me think about my double angle identities. Except cosine of 2 theta has 3 different things it can become. So I have to make a decision on which is best. All 3 will work, but which is best? I am trying to get sine squared. So I want some sine squareds involved. I have cosine squareds. So I'm going to change to the first of the 3 and see how that works. Now, in all actuality, remember, when you're replacing a single term with a double term like this, technically it's in parentheses, but nothing's happening to it, so it doesn't make a huge difference. But you got to be careful. If these were reversed, then you would have to put it in parentheses and distribute the negative. But they're not. And in fact, when I do this, cosine squared minus cosine squared cancels, gives me 0, and then 0 plus sine squared, minus sine squared is negative sine squared. Tangent of theta minus pi equals tangent theta is next. So my angles are not the same. So when my angles are not the same, I got to find a way to modify them. I see it's subtracting some things. It's not one of my cofunctions. I always double check that. So it must be a difference of tangents. So that's A, that's B. The identity says tangent of A minus tangent of B over 1 plus tangent of A times tangent of B Okay, tangent of pi is 0. So tangent of theta minus 0 over 1 plus tangent of theta times 0 equals tangent of theta. Well, that numerator is just tangent. That denominator, that becomes nothing, is just 1, which I can just say is tangent theta equal to tangent theta. Okay, next. Tangent plus cotangent squared equal to cosecant squared plus secant squared. So first off, to square a binomial, I multiply it by itself. Okay, FOIL that out. I get tangent squared theta plus. Now I'm going to get tangent times cotangent twice, so I'm just going to do 2 tangent cotangent. And I'm going to get cotangent squared. Okay, tangent times cotangent. Those are multiplied reciprocals. So this becomes tangent squared theta plus 2 times 1, which is just 2, plus cotangent squared theta equal to cosecant squared theta plus secant squared theta. Now I see tangent and cotangent squared getting added to things. Now, they're not in a Pythagorean identity together, but I do notice that in their individual Pythagorean identities, tangent squared's getting added to 1 and cotangent squared's getting added to 1. But in my actual identity, they're getting added with a 2. Well, a 2 is just a 1 plus a 1, which means tangent squared plus 1 was secant squared. And the other 1 plus the cotangent squared is cosecant squared. And write them in the same order. Okay. Now, we're shifting away from verify and simplify to finding the exact value. Now, keep in mind there's multiple ways to do many of these. I'm going to do it what I think is the easiest way. Cosine of 15 degrees is cosine of 45 minus 30 degrees. And I'm going to use a difference of cosine identity. The difference of cosine identity says cosine of A minus B is equal to cosine of A, cosine of B, plus sine of A, sine of B. So, cosine of A times cosine of B plus sine of A times sine of B. Cosine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Sine of 45 is square root of 2 over 2. Sine of 30 is 1/2, not 1/3. Multiply fractions, I multiply straight across. Square roots do multiply, so 2 times 3 is 6. In the square root, 2 times 2 is 4 in the denominator. Square root of 2 times 1 is just square root of 2 over 4. Add fractions. You need a common denominator, which we already have, but square roots do not add. So this is what we get. Sine of 105 degrees is 45 degrees plus 60 degrees. So the sum of sines identity is where we're going next. Which it is up here, sine of A, cosine of B, plus cosine A, sine B. Sine of 45 times cosine of 60 plus cosine of 45 times sine of 60. Sine of 45 is square root of 2 over 2. Cosine of 60 is 1/2. Plus cosine of 45 is square root of 2 over 2. Sine of 60 is square root of 3 over 2. Square root of 2 over 4. Square root of 6 over 4. Hey, I get the exact same answer as what I had on the previous one. Yeah, I wrote it in a different order, but it's still the same thing. If I'm ever questioning if I did it right, remember you can go to your calculator, type in things like cosine of 15 degrees, as well as type in your square root of 6 plus square root of 2 all over 4. Just make sure that when you do that, that you're putting parentheses in the right spots. Tangent is 75 degrees. Now, my brain initially says tangent of 45 plus 30. But remember that the sum and difference identities for tangent are fractions, and therefore I don't want to put a fraction into a fraction. So tangent, we avoid the square root of 3 over 3's. And the square root of 3 over 3's for tangent show up at those with the 30-degree reference angles. 30, 150, 210, and 330. So instead, I'm going to find another way to get to tangent of 75, and I will do 135 minus 60. So that's A, that's B. Tangent of A minus tangent of B. Why did I write an A? Tangent of A is 135 minus tangent of B over 1 plus tangent of A times tangent of B. Tangent of 135 degrees is negative 1. Tangent of 60 degrees is square root of 3 over 1 plus negative 1 times square root of 3. So negative 1 minus the square root of 3 over 1 minus the square root of 3 is what I have. To rationalize the denominator, I multiply by the conjugate of the denominator. And I FOIL it out. Negative 1 minus square root of 3 minus square root of 3 minus square root of 9 over 1 plus square root of 3 minus square root of 3 minus square root of 9. Those cancel because they're adding opposites. And I remember that this is a 3 and this is a 3. Negative 1 minus 3 is negative 4. And there's 2 square roots of 3's there, but both negative. 1 minus 3 is negative 2. And since all 3 of those divide by a negative 2, I get 2 plus square root of 3. Sine of 157.5 is telling me to use a half angle identity. 157.5 is 315 getting divided by 2. Using my identity sheet, which I'm not going to keep flipping back and forth from, says it's the square root of 1 minus cosine of theta. And in this case, I know what theta is. It's 315 all over 2. Positive, negative, square root of 1 minus cosine of 315 is a positive square root of 2 over 2. Okay, common denominator is 2 over 2, which when I subtract those, I get 2 minus root 2. Whoa, that doesn't even look like a root 2. There we go, over 2. Remember, there's a second over 2. Little trick is those multiply. And I square root both the top and the bottom of the fraction. Square root of 4 is 2. To determine positive or negative, remember we're looking at the 157.5 degree angle, which that's in quadrant 2, where sine is positive. Okay, moving on. Find sine of 2 theta, cosine of 2 theta, sine of theta over 2, and cosine of theta over 2. Given cosine is 1/4. The sine of 2 theta formula requires knowing both sine and cosine. So that means I'm going to make a right triangle to find sine. Cosine's the adjacent over the hypotenuse. So 1 squared plus x squared equals 4 squared. 1 plus x squared equals 16. X squared is 15, so this is the square root of 15. Therefore, sine of theta, which is opposite over hypotenuse, is square root of 15 over 4, but is it positive or is it negative is the question. Between 270 and 360, sine is negative. Sorry. Okay, now for the things we're actually looking for. Sine of 2 theta, which says it's 2 sine of theta cosine of theta. Now, I do not know theta, but I know sine of theta. I know cosine of theta. So, sine of theta, negative square root of 15 over 4. Cosine of theta, 1/4. Put that over 1, because to multiply fractions, you multiply straight across. I get a negative when I multiply these. 2 root 15, all over 16. Don't forget to simplify your fraction if possible. The 2 and the 16 simplify, so negative square root of 15 over 8. Cosine of 2 theta. I've got options on what to do. I'm going to do the 2 cosine squared theta minus 1. Again, I don't know theta, but I do know cosine of theta. 1/4 squared is 1/16. Multiply that, I get 2/16 minus 1. Get a common denominator, it's 2/16 minus 16/16. So I get negative 14/16. And don't forget to simplify your fraction. Cosine of 2 theta is a negative 7/8. Okay, now for sine of theta over 2 and cosine of theta over 2. Sine of theta over 2 says positive or negative square root of 1 minus cosine of theta, which is 1/4, all over 2. 1 minus 1/4, well, that's 4/4 minus 1/4 is 3/4. 3/4 over 2, remember the trick is those multiply is 3/8. I square root the fraction by square rooting the top and the bottom and rationalizing that denominator. I get square root of 24 over 8, but square root of 24 simplifies because it divides by 4, which is a perfect square. Square root of 4 is 2, and 24 divided by 4 is 6. And then the 2a simplifies. So I get a positive or negative square root of 6 over 4. But wait, I have to determine positive or negative. Now, since this is referencing to theta over 2, I have to look at not where theta is located, but where theta over 2 is located. And if theta is between 270 and 360, dividing all of that by 2 gives me 135 and 180. And in that range, sine of theta over 2 is going to be positive. But cosine of theta over 2, because we're in quadrant 2 right now, is negative. So I have to be careful of that. Sine of theta over 2 is equal to a positive square root of 6 over 4. Okay, cosine of theta over 2. Positive or negative, but we already know it's going to be negative, so I'm just going to be lazy and put the negative out front. And it goes 1 plus cosine of theta, all over 2. 1 is 4/4 plus 1/4 is 5/4 over 2. Multiply those, I get 5/8. Square root the top and the bottom. Rationalize your denominator. Square root of 40 over 8, but square root of 40, 40 divides by 4, so it's 2, square root of 10 over 8, which is negative square root of 10 over 4. Okay. Last thing we have is solving. To solve, you want to get the ratio alone. This looks like 2x minus 1 equals 0. So I'd add the 1. I'd divide by the 2. But I remember it was cosine, not x all along. My range is between 0 and 360. Cosine is 1/2 between 0 and 360 at cosine's x, so 60 degrees and 300 degrees. Plug them back in to check. They both work. Okay, 4 cosine squared minus 1 looks like 4x squared minus 1. Add the 1. 4x squared is equal to 1. Divide by 4. X squared is equal to 1/4. Square root. X is equal to square root of 1 is 1. Square root of 4 is 2. Don't forget the plus or minus. Remembering that it was cosine. Cosine is a positive or a negative 1/2. Now between 0 and 2 pi, that would be, and I'm not going to keep flipping back and forth, positive at pi over 3 and 5 pi over 3. It would be negative 1/2 at 2 pi over 3 and 4 pi over 3. Plugging them back in, they all will work. Okay, 2 sine squared theta tangent equals tangent. Ooh, I meant 4. This is kind of like a 4x squared y equals y. Now, that's not the prettiest thing in existence, but I can do it because they all have a y on them. I can get it equal to 0 and I can factor. If you choose to instead divide by y, just remember that you still need to give the solution that says y is equal to 0. 4x squared minus 1 equals 0 gives me 4x squared equals 1, gives me x squared equals 1/4. Hey, didn't I just do this math? I did. Okay, so y first. Y took the place of tangent. So where tangent is equal to 0, well, tangent's equal to 0 at theta equals 0 radians, pi radians, and 2 pi radians. This time, sine is what's equal to a positive and negative 1/2. And sine is positive or negative 1/2 at pi over 6. And 5 pi over 6 for the positives, 7 pi over 6, and 11 pi over 6 for the negatives. All of those will work in the problem. Okay, 26. I see an issue. Because if I just try to change this to x's and y's, I can't factor this. So not helpful. This is where an identity comes into play. I see squared trig. I see a negative 1 sine squared. So I have an identity that says cosine squared theta plus sine squared theta is equal to 1, which means sine squared theta is equal to 1 minus cosine squared theta. And I can replace sine squared with that. And then I will have all cosines. Now keep in mind, this was a negative sine squared, which means this is a negative, and in parentheses, 1 minus cosine squared. There's other ways to do that. This is just the way I chose to do it. So I get 2 cosine theta plus 2 is equal to negative 1 plus cosine squared. Okay, 2x plus 2 equals negative 1 plus x squared. It's quadratic. I like that the x squared's positive, so I'm going to subtract the 2x and the 2. While I do that, I'm going to rearrange a little bit. Put the x squared first, then minus 2x, then minus 3. Two things, since I can do the shortcut that multiply to negative 3 but add to negative 2, or negative 3 and 1. Which gives me x equal to 3 and x equal to negative 1. 3, because x was actually replacing a cosine, and cosine will never reach 3, is not helpful. So cosine of theta equal to negative 1, on the other hand, happens when theta is equal to pi. If I plug this back in, it does work. Okay, getting closer to the end. Sine of 2 theta plus cosine of theta is equal to 0. I notice an angle that's different. Sine of 2 theta is 2 sine theta cosine theta. I notice that cosine's on both of these because it's in this form, so the y's on both, so I can factor it out. So y equals 0. Subtract 1, divide by 2, and x equals negative 1/2. X was sine and y was cosine. So cosine of theta is equal to 0. We're looking between 0 and 360. Cosine is 0 at 90 degrees and at 270 degrees. Sine of theta is a negative 1/2 at 210 degrees and 330 degrees. All of these do work. In fact, generally speaking, it's very rare that you're going to get ones that don't work unless you're choosing to square both sides. Okay, 2 sine squared equal to sine plus 3. That's 2x squared equal to x plus 3. It's quadratic, so I get it equal to 0. Now, unfortunately, on this one, after I subtract the x and the 3, because I want my x squareds to be positive, that's why I subtracted those instead of subtracting the 2x squared. Unfortunately, I have to do the AC method here. So, off to the side, a times c. A is the coefficient of x squared, c is the constant. I get negative 6. Two things that multiply to negative 6 but add to the negative 1 are negative 3 and positive 2. In the AC method, I must do the rewrite. So I have to change this negative x into a negative 3x and a 2x. So I can factor by grouping. First group, I can pull out an x, leaving me with 2x minus 3. The second group, I can't really factor anything out other than a greatest common factor of 1. And in grouping, that is the only time I factor out 1 because I need the x plus 1. Okay, now I split and set equal to 0. This will give me negative 1. 2x minus 3 equals 0 would give me, add the 3, divide by the 2, 3/2. X took the place of sine. Sine is negative 1 at 270 degrees, or in this case, that would be 3 pi over 2. Sine equal to 3 halves. Well, 3 halves is 1.5, which is too big. So 3 pi over 2 is the only answer, except I want for all angles in radians. Okay, final problem. Cosine of 2 theta plus cosine of theta equal to 2. Now, cosine of 2 theta has 3 different identities that work for it. The mixture of sines and cosines very rarely is going to help us in solving unless something cancels out. Cosines, I believe, is what I had in that problem. Yep, so I'm going to do the cosine one, which says 2 cosine squared theta minus 1. Now, keeping in mind that when I replace a single term with a double, I might need parentheses. In this case, it won't make a difference. 2x squared minus 1 plus x is equal to 2 is what this looks like, which is quadratic. 2x squared plus x, I want it equal to 0, so minus 3 equals 0, and I have to factor. This one is similar to the last one, because it is AC method again. I'm still multiplying 2 times negative 3 and getting negative 6, but this time when I'm seeing what adds up, it's adding to a positive 1. So positive 3 and negative 2 this time. 2x squared plus 3x minus 2x minus 3 equals 0. First group factors out an x, leaving me with 2x plus 3. The second group factors out a negative 1, leaving me with 2x plus 3. Remember, those parentheses have to match, otherwise there's a problem. So I get x minus 1 and 2x plus 3. Set them both equal to 0. This gives me x equals 1. Set that one equal to 0. I'd subtract the 3, divide by 2. I get negative 3 halves. Cosine is equal to 1 at, in degrees, theta equals 0. Now, in all actuality, also 360. But since I'm doing all theta in degrees, by adding my 360k, where k is an integer, it's actually going to take care of the 360. If you wrote it, it would be redundant, but it's not wrong. Cosine, on the other hand, is negative, never equal to negative 3 halves is what I meant to say. So that's not helpful.